Hi everyone, in this lecture I want to discuss about the non-exact differential equation and we'll see that how to find the solution of a non-exact differential equation. So in the previous lecture we have seen that how to identify an exact differential equation and how to find the solution of an exact differential equation. Okay, so if a condition if satisfy this condition del m upon del y x equal to del m upon del y does not equal to del n upon del x, then the given differential equation is not exact. See that m dx plus n dy equal to 0, and if we will do partial derivative of m with respect to x equal to del n upon del x. So in the previous lecture we saw that if they are hold, so we say that given differential equation and exact differential equation. If this not hold, does not equal to, then we say that given differential equation is not exact. Okay, so if not exact, then how can make an exact? So this is the procedure to making a given differential equation non exact to exact. So in this case, if there exists some function fxy of two variables such that f of xy equal to m dx plus n dy equal to 0 become exact, then fxy is called integrating factor. Then one question is coming in our mind that how to find this f of xy. So there are many types to find this type of the f of xy. So in this lecture I will discuss one type. In the next lectures we will do more types. Okay, so we will see the one example. Let us suppose that this is an example. Okay, first of all we will convert this differential equation in exact format. How can make an exact? Okay, so our differential equation is that x dy dx plus 2y plus 3x equal to 0. So we can also write this given differential equation in this format: 2y plus 3x dx equal to 0. So here we can compare this standard form. What is the m? M is the coefficient of dx, so 2y plus 3x. What is the n? N is the coefficient of dy x. So del m upon del y equal to means the partial derivative of m with respect to y is 2, partial derivative of n with respect to x is 1. Okay, so del m upon del y does not equal to del n upon del x. So we can say that this differential equation, this given differential equation is not exact. Okay, so how can we make an exact differential equation? So here if we will multiply by x to the whole differential equation, then it will become an exact differential equation. How? If let us suppose that I will multiply by x whole the differential equation, so here n will become x square. Okay, here we will multiply by x, so the coefficient of dy is n, so it will become n x square, and our m will be update like 2xy plus 3x square. So the partial derivative of m with respect to y is 2x, it will become 0. Partial derivative of n with respect to x is 2x, so both are equal. So we can say that this differential equation after multiplying by x, it will become an exact dE. Okay, so one question is coming in our mind that how to find this x, how to find this f of xy. Basically this f of xy is called an integrating factor. So how can we find? So there are many types to find this type of an integrating factor. So in this lecture I will discuss only one type. In further we will discuss many types. Okay, so type first is that if f of x dy dx plus n of xy dy equal to 0 is homogeneous d. In the previous lecture we have already seen that what is the homogeneous function and what is the homogeneous differential equation. Okay, with mx plus ny does not equal to 0, then our integrating factor will be 1 upon mx plus ny equal to 0. Okay, अगर हमारी if we have a given differential equation m dx plus n dy equal to 0, and this differential equation is an homogeneous differential equation. Okay, so we seen that this condition should be satisfied, mx plus ny does not equal to 0, then our integrating factor will be that 1 upon mx plus ny equal to 0. Our integrating factor will be 1 upon mx plus ny. Now we will multiply by this integrating factor to hold the differential equation. Then it will become, after multiplying integrating factor, it will become an exact differential equation. Then we will find the solution. Okay, so we will see in one example. So with the help of example we can more understand. So let us suppose that we have an example x square dx minus x cube plus y cube into dy equal to 0. So here we will see that what is the m? M is the coefficient of dx. So our m will be m equal to x square y. What is the n? N equal to minus x cube plus y cube. Okay, so we will see that this differential equation is a homogeneous differential equation, because here the degree of homogeneous function is 3, here is also degree 3, so it is in a homogeneous differential equation. Okay, in the previous lecture we have already seen that what is the homogeneous differential equation. So here we will do the partial derivative of m with respect to y is x square. What is the partial derivative of n with respect to x? Is minus 3x square. So both are not equal, so we can say that given d is not exact. Okay, so we can say that given differential equation is not exact. So how can make an exact? If it is not exact, how can we make an exact? So we will find the integrating factor. So this is a homogeneous differential equation, so integrating factor will be that mx plus ny equal to divided by 1 by mx plus ny, where mx plus ny does not equal to 0. So it will become 1 upon what is the m? Sorry, what is the m? M is x square y multiply by x plus what is the n? N is minus x cube minus y cube divide multiply by y. So it will become minus 1 up cube y minus x cube y minus y to the power 4. So it will be cancelled. So our integrating factor will be minus 1 divided by y to the power 4. Okay, so now we will multiply by this minus 1 to the power y by 4, and given differential equation was that x square y dx minus x cube plus y cube. Okay, dy equal to 0. Now we can see that this differential equation will be now an exact differential equation. We can also verify that it is or not. So what will be our m dash? Because we have already used the m, so it will be in new notation m dash. So it will be minus x square y cube. What will be n dash? Equal to minus minus plus x cube plus y cube divided by y to the power 4. Okay, so we will do the partial derivative of m dash with respect to y equal to minus x square minus 3 y to the power minus 4. Okay, so it will become minus minus 3 x square y to the power 4 And what is the partial derivative of n dash with respect to x is equal to, so we can also write x cube plus y4 plus 1 upon y. So partial derivative of n with respect to partial derivative of n dash with respect to x is y4 plus 0, so 3x square by y to the power 4. So here we can say that del m upon del y dash equal to y dash, sorry, y, not y dash, del m upon del y equal to del n dash upon del x. So it is an exact differential equation, means this differential equation is an exact differential equation. So up to here what we have done, first of all we have a given differential equation, we check that it is exact or not. So our given differential equation was not exact, so first of all we will make an exact. So we find the integrating factor. What was that? This was minus 1 to the power y to the power 4. So after multiplying by this integrating factor, so it will become an, it is an exact differential equation. Now we will see that how to find the solution. So finding the solution of an exact differential equation, we have already seen the previous lecture, that we will see the minus x square y divided by y to the power 4 dx, where y as a constant, plus here we will see that the term should be free from y, free from x. So here we will see that after multiplying this, so it will become here, so this term is free from the x, so here is only one term. If we will multiply by this, so it will become this. So here we can see that the term free from x is 1 upon y, so it will become plus free from x, yeah, or also we can write independent from x 1 upon y dy equal to c. So here the integration with respect to x is x3 and it is y cube. We can see that y will work as a constant plus log y equal to c. So this is the general solution of a non-exact differential equation. Okay, so in the next lecture we will discuss other types of a non-exact differential equation. Okay, thanks.